If you're not excited about humans building a base on the moon with nuclear reactors and flying drones while moon buggies cruise at 9 miles per hour across a crater that hasn't seen sunlight since the Cretaceous period, what is wrong with you? For the first time since Apollo, NASA has a concrete, funded, hardware in development plan to not just visit the moon, but to live there, not as a one-time achievement, but as a permanent chapter of human civilization. It means the space economy is becoming real. Private companies aren't just building rockets. They're building the infrastructure of an off-world economy. Rover manufacturers, cargo landers, power systems, communications networks. The moon is becoming a market. It means the next generation of space explorers won't just be traveling to the moon, they'll be working there, rotating through like shifts, coming home and going back. The moon stops being a place humans went and starts being a place humans go. And for those of you who grew up staring at the sky and wondering if any of this was real, it is real. It is funded. It is being built. The timelines may slip. The costs will probably grow. Something will definitely explode that wasn't supposed to. And some engineer somewhere will have to redesign an entire subsystem because of moon dust. But the direction is set. The program is named. The contracts are signed. And the moon, for the first time in human history, is about to become home. NASA just held a major news conference on May 26, 2026, and they dropped one of the most detailed, most ambitious space plans in the history of the agency. And it's the most exciting thing happening in space right now. NASA laid out a 3-phase architecture spanning from 2026 all the way to 2036 and beyond. 79 total launches, 73 landers, $30 billion, and a timeline that assumes nothing goes catastrophically wrong, which, if you followed space history, is doing a lot of heavy lifting as an assumption. Phase 1, 2026 to 2029. Robots go first. Smart move, honestly. Don't send humans to a place until you've sent machines to figure out all the ways it can kill you. Phase 1 involves around 24 launches, delivering roughly 4,000 kilograms of payload to the lunar surface. The goal? Scout, test, and prepare. Let the robots do the dangerous stuff while humans sit on Earth eating snacks and watching the data come in. 3 missions are already lined up for launch before the end of 2026. Moonbase 1, Blue Origin's Blue Moon Mark 1 lander heads to the Shackleton Connecting Ridge. It carries instruments to study how rocket plumes interact with the moon's surface, and laser arrays to help orbiting spacecraft pinpoint locations. Essentially, does landing here break everything? Let's find out. Moonbase 2, Astrobotic's Griffin lander follows, carrying over 500 kilograms of cargo. Among its payload is the Flip rover from Astrolab, a prototype moon buggy being used to test what future crewed terrain vehicles will need to handle. Think of it as the beta test for the moon's Uber. Moonbase 3, Intuitive Machines' Nova C Trinity lander carries Lunar Vertex, a joint lander-rover combo designed to study lunar swirls, those strange bright patches on the moon's surface that are shielded from the solar wind in ways scientists still don't fully understand. It also carries payloads from the European Space Agency and Korea's Space Institute, because this is genuinely an international effort. The moon base is not just America's project, which is either very inspiring or very alarming depending on your feelings about international committees making decisions. Phase 1 also includes Moonfall, and yes, that name absolutely rules. 4 propulsive drones set for launch in 2028 that will make short hops across the lunar surface, surveying terrain and mapping permanently shadowed regions. Think Ingenuity helicopter on Mars, but in a complete vacuum, over craters that haven't seen light since the dinosaurs roamed Earth. Firefly Aerospace is building the spacecraft to deliver them, and JPL is developing the drones themselves. Phase 2, 2029 to 2032, infrastructure gets real. This is where things start looking less like a science experiment and more like the beginning of a civilization. Phase 2 involves up to 60 tons of cargo across 24 landings, Expanded solar power arrays go up. And then this is the part that makes engineers visibly emotional. Nuclear fission reactors come online. NASA's Fission Surface Power System, a compact nuclear reactor designed to produce at least 40 kilowatts of electrical power, enough to run multiple habitats, charge rovers, and keep life support running through the 2-week lunar night when solar panels are useless. Because nothing says we're serious about staying like bringing a nuclear reactor to the moon. Phase 2 also brings JAXA's pressurized rover. Japan Aerospace Exploration Agency is contributing a mobile habitat on wheels, essentially an RV for the moon. Astronauts can drive it, live in it for extended trips, and explore terrain far beyond the base perimeter. Range anxiety on the moon. Truly, humanity has arrived. Phase 3, 2032 and beyond, people actually live their continuous human habitation. Crew rotations, in situ resource utilization, meaning they're mining the moon's ice and converting it into water, oxygen, and fuel on site. Up to 38 tons of cargo per year to support the growing outpost, semi-permanent habitats that evolve into permanent ones. This is the phase where moon base stops being a project name and starts being a place, a real place where humans live on the moon. Why lunar South Pole for moon base? No one just picks a spot on the moon randomly. Well, actually, the Apollo astronauts kind of did. They were mostly landing wherever they could safely touch down with the technology of the 1960s, which, bless their hearts, included computers less powerful than your microwave. But NASA in 2026 has a very specific address, the rim of Shackleton Crater at the lunar South Pole. Why there? 3 reasons, and they're all excellent. First, sunlight. The peaks along Shackleton's rim receive near continuous solar illumination. On most of the moon, you get 14 days of scorching sun and 14 days of complete darkness, which is, as engineers politely call it, a nightmare for power systems. But the South Pole's rim, near permanent sunlight, like the moon's version of a rooftop solar panel setup that actually works. Second, water ice. The permanently shadowed craters nearby, regions that haven't seen sunlight in potentially billions of years, are packed with water ice. And water ice on the moon isn't just for drinking. You can split it into hydrogen and oxygen. Oxygen for breathing, hydrogen for rocket fuel. The moon could literally become a refueling station for deep space missions, a cosmic gas station, with, one assumes, horrific coffee. Third, strategic positioning. It gives future missions to Mars a staging point. You go to the moon, master the hard stuff, living in a radiation-soaked, airless environment, and then you go to Mars. The moon is the tutorial level, a very difficult, very cold tutorial level. The moon buggies. Yes, there are moon buggies. Can we talk about the rovers for a moment? Because NASA just handed out contracts worth hundreds of millions of dollars for what are essentially the most extreme all-terrain vehicles ever conceived. 2 companies got the nod. Astrolab, $219 million. Their crewed lunar vehicle can fold up for transport, carries astronauts and supplies, and can hit over 6 miles per hour on flat terrain. That might not sound fast. On the moon, with a quarter of Earth's gravity and no air resistance, 6 miles per hour feels like flying. Lunar Outpost, $220 million. Their Pegasus rover can be driven manually, operated autonomously, or controlled remotely from Earth. Top speed over 9 miles per hour. It can literally drive itself around the moon while the astronaut crew is inside the habitat watching the footage. Blue Origin, yes, Jeff Bezos' rocket company, won the contract to actually transport both of these rovers to the South Pole. The man who sells you shipping subscriptions on Earth is now literally shipping moon buggies to the moon. The circle of commerce is complete. Who's involved? The team. This is genuinely a we're all in this together moment for the planet. Maybe one of the last few we get, so let's appreciate it. International partners confirmed so far include the European Space Agency, JAXA, Japan, and KASI, Korea's Space Institute. The Moonbase 3 mission alone carries ESA and Korean payloads. On the commercial side, this reads like a who's who of the new space economy. Blue Origin, Astrobotic, Intuitive Machines, Astrolab, Lunar Outpost, Firefly Aerospace. These aren't just contractors building parts, they're co-investors in the lunar economy, expected to develop capabilities that can be sold to other clients, other nations, other missions. NASA Administrator Isaac Mann made the philosophy clear. Leverage commercial industry, build reusable infrastructure, and treat the moon not as a destination, but as a platform, a stepping stone to Mars and beyond. And speaking of Mars, multiple speakers at the conference framed the entire moon-based program as the prerequisite for Mars missions. Master low gravity surface ops, fission power, ISRU, crew psychology over long durations, solve all of that on the moon 3 days from Earth before attempting it on Mars, which is 7 to 9 months away and offers no rescue options whatsoever. The reality check. All right, we've been very optimistic. Time for the reality check. $30 billion is a lot of money, but it's also a number that has a long history of getting larger. Space projects don't typically come in under budget. The James Webb Space Telescope was originally estimated at $500 million and ended up costing $10 billion. And the Space Launch System took 12 years and $23 billion before it flew. So when NASA says $30 billion through 2036, veterans of space program accounting hear that and nod slowly, like a doctor looking at x-rays. Timeline pressure is also real. There's an explicit geopolitical dimension here. China has its own lunar ambitions, and the race to establish presence at the resource-rich South Pole is very much a factor in how urgently NASA is pushing this. The first country to establish a permanent base there will have enormous strategic and scientific leverage. This isn't just exploration, this is positioning. And then there's the sheer technical brutality of the environment. And the lunar South Pole experiences temperature swings from negative 280 degrees Fahrenheit in shadow to over 250 degrees in sunlight. Radiation exposure without Earth's magnetic field for protection. Micrometeorite impacts with nothing to stop them. Dust so fine and chemically reactive, it damages equipment and lungs. So now it will be very exciting to see what the future holds for us space lovers.
We are leveraging the NASA playbook from the 1960s, figuring out what works and what doesn't in this epic science of survival, because the moon base is as beautiful as it is hostile.